Assalamualaikum and good afternoon. Today we will discuss a tutorial for Francis turbine. So we go for question number 5 here. A Francis turbine works under an effective head of 70 meters of water and flow rate of 1000 liter per second. The inner diameter is half of the outer diameter. Runner rotates at 350 RPM and the runner blade angle at inlet is 40 degree. Blade thickness occupied 10% of the circumference flow area at inlet. Flow velocity is constant at 2.5 meter per second and assume zero whirl at outlet. If overall and hydraulic efficiency are 80% and 85% respectively, calculate the inner and outer diameter of the runner, guideband angle, blade angle at outlet, runner width at inlet, and the output power. So to solve this problem, first you need to draw the velocity triangle. So this is the velocity triangle. So I hope you could draw the inlet and the outlet. So normally for the outlet here, we could assume that V whirl 2 is equal to 0. Okay. So and then we list all the parameters that already given in the question. So and then I hope you could remember the equation for hydraulic efficiency and also the overall efficiency. So normally the equation for overall and hydraulic efficiency will not be given in question. Okay, and then from the so first question here is to calculate the inner and outer diameter of the runner. So usually we could get inner and outer diameter by using this equation. So and then what we need to do here is we need to calculate the value of U. So from the inlet here, so we know that the angle is 40 degree. So and then I hope you already know how to develop this one. It is depend on it is the tangent 40 for this triangle. Okay, so we could have this correlation. So and then we could rearrange the equation to have this term. So and then because this it has two terms, V1 and U1, so means that we need to have another equation to do the simultaneous solution later on. So and then we use the hydraulic efficiency here. So this is the equation of hydraulic efficiency, and then we substitute the value, everything. So and then we could get that we could get another equation like this one. So and then from these two equations, we could find the value of U1 because it is a quadratic equation here. So we could get 13.49 and minus 10.5. So if we have one positive and one negative, so for sure we could neglect the negative value. So if we have two value in positive term, usually we take the common the acceptable range of velocity. Usually it will become one is too big or too small and another one is acceptable value. So if the value is around 13 meter per second is also is okay, but if the velocity is 1 meter per second maybe or 0.1 or too big, maybe 90 meter per second for 90 meter per second for example, so please neglect the too small value or too big value. So in this situation it's quite clear because one of them is negative value, so we neglect the negative one, so we take the positive value 13.49, so we substitute into this equation, so we could get the diameter. So because in the question it gives us idea of the inner diameter is half of the outer diameter, so and then we could have this term. Okay. So we go for the next question, which is the guideband angle. So here I think you already know. So let's say we have a blade here. So and then the guide angle is actually a fixed blade, a fixed vane attached before the inlet. So it is used to make sure that the inlet velocity will flow at specific angle. So this angle is actually the angle of the actual velocity. Okay, so and then according to the velocity triangle, we could have these terms. So and then we could substitute the value. So we already know the value of u1 here. So and then we could get that the alpha, the angle is 13.4 degree. So the third one is the blade angle at outlet. So the blade angle, if we see the velocity triangle here, so it is okay for us to take this angle. So because it is reflect the shape of blade. Okay. So and then from the velocity triangle, we could draw the beta 2 here is Vf over U2. And then we could calculate the value of U2 here by using this equation. And finally, we could calculate the value of beta 2 is equal to 20.35 degree. Next, we are going to calculate the runner width at inlet. So here, please make sure that you really understand the word width here. So we have a blade here. So, and then the blade is attached on a runner. And from the question, it gives us the value of diameter, inner and outer diameter. Okay, and then what we need to do is we need to calculate the width. So, and then the equation that contains the parameter of width is this one, because it is actually the flow rate. So we have Q equal A times V. So we have V is equal Q over K pi dB. So and then we could calculate this one. We could get the value of B is equal to 0.1922 meters. And the output power. So the output power here, you must understand that if we have turbine here, so the power of turbine is actually come from the water inlet here, which has a lot of potential energy. So the energy from the water here will transfer to the turbine, and turbine will rotate the generator and so on, and then it will produce power. So the power at this point is actually the output power, means the power before it's going the national grid. So according to here, so we could found that this is might be okay. If according to this, might be we need to calculate here the effective head, and then this is the output head. So and then this is the equation for overall velocity and the overall efficiency. So we could calculate the output power as 133.4 kilowatt.